Hey guys, welcome to the channel. Today we're going to be talking about using the Librealsense SDK with OpenCV and compiling it with Cmake. So this is going to let you do pull in some camera depth frames, some infrared frames, kind of display them on OpenCV, and kind of talk a little bit about some of the extra stuff you could do with OpenCV if you were so inclined. And then also how to actually build your own Cmake file and go about generating that and compiling. So cool. All right, let's get started. So the first thing you want to do is, I've already got it open. These links will be in the description. But first thing you want to do is download the Librealsense SDK. So we go to their main GitHub page and you scroll all the way down. Depending on what operating system you're on, this is going to differ a little bit. I'm obviously on Linux, so we're going to go ahead and select that. And you're just going to be able to run through some of the examples. So I'm on Ubuntu 20, but Ubuntu, the instructions for Ubuntu 18 will also suffice. So if we go ahead and copy this, I have already done this, so this should be saying that I've already got things. Oops. If I could remember my password, that'd be cool. There we go. Alright. Go ahead and just split this over. And then it's going to say we want to install libraries, which is true. We also are going to want to install the developer dev packages. So I'm going to do... Okay. And as you can see, all the packages were already installed because I've had this before. Okay, and then it also on the same page discusses how you can upgrade and uninstall if you decide that you don't need it. So some of the things that it comes with that we want to check to make sure that this is actually working. First thing you're going to do is I'm going to take my Librealsense camera here that I've got. I'm going to plug it into my USB. Now I'm going to do is I'm going to go ahead and do Realsense, and if I just start tab complete, I should get Realsense Viewer. Let's go ahead and boot that up. And if Realsense Viewer came up, then you know you actually installed the SDK properly. So it's saying that my camera, it did recognize my camera. Intel Realsense D435 is the one I've got here. Connected to the USB 3.2. And then it's saying that I've got an out-of-date firmware. So I'm actually going to dismiss this for now, but this is something that you'd want to upgrade. Let's just go ahead and grab some stereo vision real quick. Aha! That's pretty neat. Grab the RGB. Cool. So those are working. I can go ahead and close this off. I now know that I've got that installed. Okay, so now the next step is we're going to want to install OpenCV. So I'm going to be installing OpenCV 4.3. Now if we go to the main GitHub page for Librealsense, we go back here, we go to the wrappers and go to OpenCV. We are going to notice that they specifically tested for OpenCV 3.4. I've done this with OpenCV 4.1 and 4.3, and it's worked just fine. You may have a small issue with some of the imshow ones, some of the basic examples. The reason I like to run 4.3 is because it also allows for the DNN package, which is, DNN library, which allows for some machine learning to be done through OpenCV specifically, and in conjunction with the Librealsense camera, that makes for some pretty cool projects. So let's go ahead and get going on installing OpenCV. This link here will be in the description of the video. So first thing you want to do is select your version. I'm going to select 4.3. This is already installed for me. And go ahead and run through these examples. Again, all of these should already be installed for me. This optional one, maybe not. Nah, we're good. So the way I like to do it is install from the Git Repo. So I follow the Git Repo instructions for installing. The main reason for this is that the source code, actually, I can't seem to find it available for Linux. So if you're on Windows, that's awesome. Go for it. It's going to be a much easier install. But for Linux, we're going to actually install it from the Git Repo. So if I go over here, back to this page. So first things I want us to do is create a working directory, so that's fine. So I'm going to make a dir OpenCV. I may actually have one. Yes, I do. So make actually rm. I'm going to call this OpenCV tutorial. So first thing we want to do is then we're actually going to clone OpenCV. So go here. So now there's a couple steps that's going to happen here. So we clone the OpenCV. If we wanted to, if we go to the actual OpenCV repo here, and we go to the tags, we could check out 4.3 or 4.4. I'm going to leave it at 4.4 because, again, I do know that that's what I currently have installed and it hasn't caused any issues. But if you were curious or you need a specific versioning, this is how you would do it. You would check out the tag and then run the next steps we're about to do after this. So we're also going to download the OpenCV contrib. So this just has some extra libraries and for some other projects you may want to do in the future. You might as well just do it now. So I'll fast forward through this as it goes. Alright, cool. So we got those installed. And first up, now we're going to go down to here. It's going to want us to go into OpenCV. So if we just go in there, we're going to want to make a build directory. This is pretty standard with Cmake. So I'm going to go do that. I'm going to cd into it. And now this is where you have some freedom to kind of choose what you actually want to compile. So you're going to actually configure the run for Cmake. So Cmake allows you to pass in some arguments. So this is going to say I want to build for release. I also want to install into user local. There's also down here a list of other parameters you could actually add in for certain things you may want to do. For us, we're just going to stick with the standard example here. Copy this. Just going to run through, make sure it's detect everything. So you notice should be passing success. Unless something specifically fails that throws an issue that you can't actually configure Cmake or run through the whole Cmake process, you're usually going to be okay just letting this run and not worrying too much about if it's found or not found. Cool. So we notice here that we've got build files been written. So what we can do now is run the make command. So if we go, you can see this actually in the instructions right here. They do mention that the optional argument J7, J being the argument and 7 being the number of threads you want to run this in parallel. So this is very important that if you say you're running this on a Mac or just a system that's got a low level of threads they can actually pull up, you want to make sure that you don't max this out. So for me, I know that I've got enough threads. I'm going to just run this at J4, which is a moderate time or moderate amount of threads to hopefully lower the compilation time. If you were to run this just without the J flag, it's going to default to 1 and it's going to take a hot minute. So I will fast forward through this once it's compiled, but we're going to go ahead and just let this run. Woofta! Alright, so that took about 20 minutes to build. So next step is to actually install it onto the system. So I have already done this. We'll see how long this takes for my particular system. You're going to run sudo make install. You can actually see the command right here. You want to make sure you do this with sudo or at least root privileges because it is going to try to get added to your actual system path. So we're going to go ahead and do sudo make install. It's going to ask for my password. Cool. So I'm not sure how long it's going to take for you the first time, but for me it took like 5 seconds. Alright, so now we have that. We should have everything we need to actually go about making our own basic Librealsense OpenCV combination script, and then from there I can also show you how to compile the examples that Librealsense sends in their SDK. So what we're going to do is we're actually going to go back a directory. So we're going to go back to. So I've got the OpenCV contrib, and this doesn't need to be done in the same directory. I'm just going to keep them all together, but I'll make a directory called tutorial, cd into it. I'm going to open code for it. So I'm using Visual Studio Code. I'm going to make a new file. I'm going to call it tutorial.cpp. Alright, the first thing we're going to want to do is we're going to want to actually include the OpenCV library. So standard include. We're going to actually do OpenCV, OpenCV2, and then we want to include the OpenCV.hpp. And then we also want to include the Librealsense library. So we're going to go, it's Librealsense 2, rs.hpp. Don't be too concerned if they don't auto-populate on tab complete, because on OpenCV, sometimes it just has a hard time with the Visual Studio Code finding it. As long as we compile at the Cmake step, obviously you've got it included. So we'll know at that stage whether or not it's actually there. Okay, then we're just going to do our standard int main. I'm not going to do any arguments or anything like that. First thing I want to do is actually set the window size. So I'm actually going to do that outside of the main, now that I realize that. Set some const. We're going to do, there's actually a variable involved with the Librealsense that we can do for the size. However, I am realizing, oops. Okay, we got those. We also are going to need one more thing. We're going to need the CV Helper.hpp. So this is actually a file that's included with the Librealsense SDK and their wrappers. And basically what it does is just has some basic functions for converting a Librealsense frame into an OpenCV mat. This lets you then display it and do some cool stuff with it. You can easily write this yourself, but they offer it, so we might as well use it. So I'm going to include it, and then I'll go find it and add it to the thing. Add it to our folder. It's going to be cv-helpers.cpp. Sorry, hpp. It's a header. All right, so we go back over here to our terminal. And actually what you're going to want to do is, if you go over to your Chrome and you see you've got Librealsense, and we go to wrappers, I think I actually have open another tab, but we're just going to go for this. OpenCV, this file right here, CV helpers HPP. Rather than clone the whole repo, I'm actually just going to copy the raw. And we're going to go back over here and make a new folder, a new file. CV helpers.hpp. Oops. Okay. So now we got that included. That's not freaking out anymore. Alright, now we can go do your standard main. I'm not going to do any arguments into it. We're just going to do basic stuff. Before this, I do want to set the size. So we're going to do width and height of the window. So the width and height of the window is going to be the width and the height that OpenCV display window is going to be. I like to sync these up to be the actual one of the possible resolutions for the camera. So one of the options that is lower resolution that I'm going to use is the 480 by 270. So 480 width, 270 height. So obviously not a great size, but it's good enough for an example like this. If you want to see all of the different sizes you could do for Librealsense, open up the Librealsense viewer, and you can actually see adjust that sizing based on the stream you want to actually grab. We're going to do const size t. We're going to call this, we'll call it window width. I can type. Cool. So we've got the window height and width set. Now inside of main, what we're going to want to actually do, so we're going to actually do, I'm going to, actually, you know what, sorry, not in main. I'm going to do some namespacing here. Just make it a little bit simpler for typing. Again, user's preference, whether you want to do this or not. If you want to type it all out beforehand and make sure it's all namespaced properly, each call you do, that's fine. I'm going to do this one, so using namespace. I'm also going to be using namespace rs2. So OpenCV and then Librealsense. So now in main, now that we're kind of cooking with fire, I'm going to want to set a couple things. So the first thing you need to do is you actually need to set up the pipeline and the config for the camera. So Librealsense offers a decent API, and you basically need to make a few calls to get this rolling. So do namespace. And we're going to do a config. I'm just going to call it CFG. This is pretty standard to their examples. That's why it's you might see this quite a bit. We next need a pipeline. Now, a pipeline is actually just an interface for the video module. So you set the config. You can pass in parameters that you want to do for adjusting resolution, things like that. Then you pass that into the pipeline. And the pipeline is what actually gives you the ability to kind of pull out the frames and get access to those things. The other thing you could do here, I'm not going to do it now, but you could also run a RS align. So this is if you were pulling like a camera or an infrared frame, and then you also wanted to pull a depth frame, but you want to make sure those two were in sync because they come through. Librealsense offers the streams that they provide can come in at different time intervals. So if you wanted to make sure that your depth camera corresponded with your infrared camera that you're seeing, the streams that you're seeing, you would align them, and basically whatever one comes in first, it's just going to hold it until the next one comes in, and they're going to sync up, and then you can just continuously see perfectly in line camera frames. This is one of the things they do with the RealSense viewer. If you were to try on multiple, you can actually see them synced up if you wanted to. All right, so now we have this. I'm just going to go look over at my little cheat sheet over here. We are going to want to go ahead and set up a window for OpenCV. So I'm going to do what's called a named window. If I can type. And then I'm going to pass it in the name, and then we're going to actually allow it to do an auto size, and then we're going to size after. So we're going to do a tutorial hello. And then we're going to let it do window auto size. Okay. So that'll be for the OpenCV window. And then we're going to come down here. Gone. So next we're going to want to set up a, we want to get those frames somehow. And currently they're basically all going to be access to the pipe. What we want to get access to is when we call the pipe and we call get frames is the function we're going to call, or the method we're going to call on that. It's going to give us all the ones we want. We then can just specify the specific ones that we want to be able to see. So I'm going to use the auto keyword here. Just let it set it up. Call it data. Again, pretty standard tutorials. Pipe dot wait for frames. So this has a couple options. Basically what's going to happen here is it's going to attempt to get all the frames it can from the camera. You could also set up a try wait for frames and then pass in a specific timeout. So basically, I think the default for this, without having set a timeout, is 15 seconds. So if you didn't have a camera connected, or there's a problem with your camera and you try to call the frames, this is going to be kind of a blocking call on your code. So just be aware of that if that's something you want to do. If you want to do a try and your stuff is pretty time sensitive, and if it doesn't work within 2 seconds, you need to move on or just execute a different block of code that lets the user know, you're going to want to use a try wait for frames. Okay. Next thing we're going to do is we're going to actually want to make sure all the frames get spatially aligned. So we're going to want to make sure that they've come in and then we've actually got them processed correctly with each other. So it's basically doing like a filter to get that in together. If you want to know more about that, you can go look up the actual documentation for Librealsense and the align function. But basically all it is, you just reassign data equals to the align to, and then we're going to call the process method on that. And we're going to pass in data, so we're going to basically just reassign it from its own self. And now this is where we actually get our frame out. So I'm going to use the infrared frame specifically because I want to kind of show what it looks like, because a lot of these examples for the wrappers show the depth frame and stuff. So again, you can use the auto keyword, which is pretty useful. I'm going to call it the IR frame. Seems pretty straightforward. We're going to call data.get, and then you can see you got the different options: color frame, depth frame. We're going to go down to the infrared frame. Should call that method. So now at this point, the IR frame contains an actual RS2 frame. However, we can't display this. We need to convert this over to a matrix for OpenCV to actually display. So that's when the CV helpers actually come into play. If we come and do, let me look at my little cheat sheet here. Make sure I tell you guys the right information. Yep. All right. So all we're going to do is we're going to call a simple. We're going to assign a matrix. I'm going to call it IRMat. So this is going to be the matrix version of the IR frame. Basically, all that's going to happen is I'm going to assign this now. You can do this in one line, but this kind of makes sense to me to kind of show the difference. And we're going to do frame to mat. So this is a function that comes from the actual helper. And if I could type, that would be cool. And then we pass in the actual infrared frame from R2. So if you want to see more about what that actually does, you go to helpers and see frame to mat. So this is the actual code that's getting executed now that we're doing that. It's pretty simple. Basically just takes the width and height and then constructs a matrix built on that. All right, and now what we should be able to actually do is just display the image. So we should be able to actually show the matrix. And I'm realizing actually that I completely forgot a step. So we've got the config, we've got the pipe. What we actually want to do is we need to enable the stream, but we need to do it and set it in the correct parameters. So if we do CFG and we want to do enable stream, all stream, we just want to enable the one, enable stream. We want to tell it exactly what stream we're going to want to enable, and we're going to tell it resolution and the frame rate. So if I do RS2, you can see it's trying to pull up some for me. I want to do stream infrared. So we're looking for that right there. If you were doing depth, you'd pass in depth. If you were doing, actually, I don't actually remember what the other streams are, but that's where you'd assign that. We want to do the, you can see here, we're going to want to do the width and height. So we're going to do 480, just as we had previously, by 270. And then we're actually going to do what's called RS2 format. And then we want the Y8. The easiest way to determine what this should be is if we actually go to the Librealsense viewer. It gives you options and you can kind of choose. So we're going to go stereo mode. I want infrared 1, close that. Right here I can either be Y8 or Y16, so I'm going to go lower resolution, and then here I can actually see the current resolutions I can pick. So different streams have different resolutions you can actually pick. 480 by 270 is right there. And then we are going to select a 6 FPS because we really don't care that much about it, but you can go all the way up to 100 if your system can support that. Close this out real quick. Oops. So the last step is frame rate, so we're just going to do 6. There we go. So that's enabled. Now we just need to start it. This we're going to run the actual start method on pipe. We are going to get a return from a config, so I'm just going to hold on to that in case we want to use it later. Do pipe.start, and then pass it in the config you just set. So these configs can be a little confusing at first. Basically, the core that you really care most about is the CFG and the pipe. This one pretty much doesn't get used except for certain projects that you might want to, that you might need it. But for what we're doing today, this is just a return that I'm capturing that I'm going to just hold on to. So we've now got this. Basically, what we can now do is we can display the window. So we will do an imp show, and because we've got the auto size set up and we're pulling the stream for 40 by 270, it should just resize to that for us. You can also use just standard OpenCV, the image show stuff, to set your own sizing when you constructed the actual window itself. So we're just going to do ImShow. I'm going to pass in the name. So I called it tutorial hello. And then I need to just pass in a matrix. So I'm going to actually pass in our IR, not our frame, but our IR matrix. So IR mat. Cool. So that should be pretty much as straightforward as it gets for that. So the last thing we're going to need to do is we actually need to make one more file. We need to make a Cmake lists.txt. And we're just going to make a general, pretty simple Cmake. So first thing I'm going to do is just put a little comment. First thing we're going to do is we're going to make this set the required version. I like to set this pretty low. I'm going to set it to 3.1 just to allow the user to actually compile. If you're doing something specifically like what I mentioned, and I'll show you with DNN where it needs 4.3, then you'd want to up that obviously. So I'm going to setting min version, and you're just going to do Cmake. It's going to be minimum required. And then we're going to set version, and then you just pass in the value that you want. Cool. Now you want to name your project, so you should call the project. We're going to call this tutorial. So this is what's actually going to be when you execute, or when you compile, the actual binary is going to be named whatever you put in there. So this is what you'll actually pass in, so that's where you kind of can change that. We're going to want to make sure it can find the package. We're going to want to find OpenCV, so we're going to do find package. then it's going to be OpenCV, and this is required, so we're going to pass in a required flag, so if it can't find that, it's going to error out. If you don't do that and it can't find it, there's a chance you could actually get through it and then wind up with some issues later on. You'd rather catch it now. We're going to set the dependencies, so we're going to append to the dependencies. If I could spell, that'd be really cool. We want to make sure we get Realsense 2. And then we're also going to pass in the libraries for OpenCV, and we're going to do this with the environment variable, so OpenCV, and then libs. Cool, so that should set that. You could also do like a message that says, hey, I found this, or the version of OpenCV, so we can do that. So we do message, we can call it a status. We'll do another environment variable, OpenCV, match the actual package name, and then you can just do an underscore version. And that should get you output of the version. So if you're going through and you're having issues and you need debug, or someone else is building this, some of your code, if you're on a team, this lets you make sure that they know they're on the correct version, and if not, then you can go fix it. Last thing we need to pretty much do is add to an executable. And there's a bunch of ways of doing a lot of the same stuff I'm doing here. This is just how I prefer to do it. So if you have a better way, or you're thinking, oh, that's inefficient, whatever, that's great. Go do it that way. Fully, Cmake is not my expertise in any way. So take everything with a grain of salt. Then we're going to actually just pass in the name. So we're going to pass in tutorial.cpp, the CPP file, and we're also going to pass in the CV helpers.hpp. Get both of those in there so we can link them. And then set the property. So I'll go here, property, pass in the target variable. We'll do the tutorial name, and then C++ 11. So property. I got my little cheat sheet over here. This is why I keep looking over. Make sure I don't type anything wrong. Okay, and then we're just going to link the libraries at that point. So libraries, tutorial, and then we just link it with our dependencies that we passed in so it knows what it's got available. Cool. That should do it. So if we go ahead and go to terminal, we should see what I broke. So let's make this full screen. So what we're going to actually do here is a standard Cmake build process. We're going to make a directory called build, cd into it, we're going to go Cmake, dot to Cmake, find the Cmake list, so directory back. Could not figure out, I typed something wrong. Tutorial, and I spelled it wrong. Wow, I did it. Oh, well, maybe let's see. Let's just do a click over, make sure this all looks good again. Tutorial, dependencies. Tutorial, we got CPP, CV helpers. Okay, let's give it a round 2. That's supposed to be a link library for targets. Can you give me a sec to figure this one out? What did I type wrong? Okay, I found it. I'm just stupid. I just put a comma when I shouldn't have had a comma. So there we go. Build files generated. Everything looks good. Now we're going to do make. I'll do J4 again. The more threads you can give it, the better. What did I mess up? Constantly. Did I just put that outside of a namespace when I should have? I believe I probably did. That would be silly of me. I forgot to do an include, I believe. Let us see here. Oh, I just spelled it wrong. I'm stupid. Let's see what the other error was. Line 2 is not declared the scope. That may be actually outside the scope. Oh, yes. Completely stupid of me. So I didn't define a line. We are actually going to align it to itself for the RR stream. So I'm just going to do an rs2 namespace align, and then we're going to call it align 2. That's what's going on. I was being silly. And we will call it, we will align it to the rs2. Oops. And the stream, the infrared stream. So now it should be defined. Everything should be good. Probably get away without those lines in general. Cool, so it's built, so let's give it a shot. Tutorial. And close down. Let's see. It closed down because, again, being silly. It ran a single one and then stopped. So what we want to do, actually, is wrap this guy. Nice little while true. So that should constantly run. Remake it. Remember, each time you change the file, you gotta make it. Realize for some of you that might have been a redundant statement, but I know when I was starting out, I did not realize. See here, it's gonna go. In general, let's just throw a little wait key here. Just so we can get out of this properly. That shouldn't have changed the ability to actually run. Let's just take a look. Okay, yeah, so we just need the wait key. Being silly. So now, look at that. We've got our own little camera frame coming through. You can see. And so we got the infrared frame. And it looks pretty good. 6 frames per second. So any glitchiness there is because of that. Close this. And I actually have to control C through that. You could also add in at the end here some catches. You could wrap all this in a try catch and do some catches for the standard error stuff for Librealsense that they provide in some of their examples. We're not going to do it now, but I will we can show it to you in some of their example stuff. Next up here is if we actually just go to, I'm going to show you how to build their actual examples, but congrats, you just built your own Librealsense OpenCV package with Cmake. Apologize for some of the weirdness with the Cmake, that was a little strange of me. Awesome, so now that we got that working, I can show you how to do some of the Librealsense SDK examples for OpenCV. Librealsense provides a wrapper around a lot of other different tools like Unity, Unreal Engine, Python, and specifically we're going to look at the OpenCV ones. So the first thing you need to do is actually clone the Librealsense repo. That's this main guide that we showed you in the beginning. It'll be in the description down below. Go ahead and clone it down. Once you do that, you're going to go inside of it and take a look at the wrappers. So inside of here, it shows all of the different things you can build Librealsense around. So you've got OpenCV, Node.js, which is really cool, Python, Unity, all these really cool things. I encourage you to take a look at them. The Unity one specifically is really cool too. So if we want to go into OpenCV. I want to take a look here. So we've got things for depth filter, imshow, DNN, grab cuts, latency tool, all these different cool things. Imshow may be a little funky for you. I did have a couple issues with that. Specifically, though, what I want to show you is my favorite, which is DNN. DNN is actually, OpenCV allows you to actually run inference models through itself. Basically, it does the TensorFlow in the back end, and then it'll actually let you load in a protobuf file that will do full image recognition or object detection. In this case, it's doing a cafe model, and it's doing object detection with the bounding box, and then it takes the center pixel depth. It actually averages all the pixels inside of there and actually does depth on that. But it's a really cool way of doing fairly rudimentary depth detection and object detection in one. It's really cool. It's built in. So what we're going to actually want to do is we're going to go inside of it. And now I already made a build folder, but let me remove it just so we can do this together. So first thing you're going to do, you'll notice it's going to be like just like everything else. But really the key, or just like the initial repo, sorry, and just like the initial project we did in the beginning of this tutorial. one thing we want to note though is that this may work for you out of the box. It may not. I had to edit the Cmake, so if we actually go ahead and edit that, I can show you what I did. First thing I had to do was I had to actually set this guy right here. I needed to set the p thread. I need to basically tell it that, hey, I want you to use threading through this library, and I want you to be able to access it. Basically, I just needed to be able to find it. And then the other thing is it couldn't find OpenCV with how it was placed. OpenCV, the way we installed it, is going to want to put it in the user local, and it somehow could not find it there. So basically, I just set a flag into the Cmake, or set a argument that said find the package OpenCV and force it to be required. Once you do this, you'll actually get a printout on Cmake that'll say found OpenCV 4.4 or whatever version you're using for the tutorial. And then the last thing I do is I set the dependencies. I basically append to the dependencies. I say, okay, I want to add the Librealsense 2. This was critical because for some reason it couldn't find its Librealsense. I believe it was the timing or something with the Librealsense. And then I also want to include the OpenCV libraries. And then on top of that, later down here, it actually already adds the dependencies. But if that wasn't there, we need to target link that as well. So it's really just these 3 lines right here. This one, and this one that you may need to add. Feel free to try this without it at first, but for my particular system, I definitely needed it. If I close out of that, what I can now do is I can just do a Cmake from the build, for seeding the build. Oops, did I not make the build yet? Oh, I haven't made the build yet. So it's going to download the actual cafe model. That's what it does the first time there. And it said, okay, build file's been written. Looks like we're going to be good. So I'm going to actually run make-j8. Cool. So there were no errors, it built, and now I should have an rsdnn. So if I run this will be pretty cool. It says person, and I am about 0.3, 0.4 meters away. So that's pretty cool. It does a lot of other objects too. I think if I maybe held my phone up, it might get phone, or it thinks chair. Well, again, this is just a starting point model. So if you had your own, or you had trained your own, you could pretty easily feed it into this guy and do some pretty cool stuff. So cool. So with that, that concludes the tutorial. Please leave a comment about things you liked, didn't like. Thanks for bearing with me on some of the slightly different flow on this one. I appreciate it, but please like, subscribe, and let me know what you want to see next. So I'll probably be putting out a new video in a couple weeks. Thank you. Bye.